lesson 2, because it's going to be a little different than the one posted online. Okay, so here's a recording of the lesson today, and let's share my screen. Again, so what was chapter 3 is now chapter 4 in the second edition of the text. And so this video, some of the references on there are to the older version. In fact, you'll see this say chapter 3 right there in the title. It is actually chapter 4. That's why I'm recording this lesson, because we'll go over the material. And I've updated, it's basically the same material, just updated for Visual Studio 2019. And the same with the textbook. The textbook material from the first edition to second edition is basically the same. It's just a change in the chapter number. That's why I think this video is still useful here, though it's using an older version of Visual Studio here. But right here, we'll be doing this. There's a GitHub link here, a couple of them that I'll be jumping to in a sec and working with. So let's bring up the chapter and kind of go over that. So we'll be talking a lot about interfaces here. Now you should have had interfaces covered. Probably, do you get to them in 2087? Do you do interfaces in Java 2 now? Does Chris do that?
I think he touches on them.
Yeah, and then you probably do them in data structures, I would think. Do you?
Yeah,
do a lot of them in data structures, I would hope. So, but again, if you need a little review of that stuff, there's some additional resources here. Some of them are Java versions here, and the first two are just Java resources on patterns. If you want to just do a quick refresher course on what patterns are and what you probably covered earlier in these courses. These two are just some more examples of object patterns that use interfaces or different patterns that use interfaces. They're slightly different. They're covered in the textbook, but they're slightly different. And sometimes it's nice to see another example here. So that's why there's a couple additional optional resources posted there. Okay, so we're going to look at interfaces. So what is an interface? It really tries to define a relationship between two things. I've thought of it different ways. Sometimes I've thought of it as kind of when you have like a main program talking to another object, you can hard code those things together in some ways. But when you hardwire them together, you create a new object, you call that object exactly. It's hard. I mean, you basically wire it directly together. It's hard to undo that when you want to. And some obviously places where you want to undo that are like for testing. When we want to test the object, we want to unhook it from like the main program or other objects it has. And if it's hardwired, it's really hard to unhook of it. So one way of thinking of it is, think of physical things. We've been working with physical things for so long, everything almost has an adapter. So here, let me stop sharing a little bit and show you this. Okay, so why aren't I seeing it? Okay. I'm still only seeing.
Are you like trying to pin yourself?
I'm trying to pin me and not Joe.
Go to your, yeah.
Pin. That's okay, good. I'm becoming Zoom expert. So this is a power supply for a computer. And you'd say, well, on this end, it looks like it's all hardwired in there. But these are all what we call interfaces in that they're all plugs. So there's lots of different size plugs. There's a number, this is a 6-wire plug here. This is a 4-wire plug. This is a different size 6-wire plug. This is a big, bandwidth plug. There's all these plugs. And what's nice about this is that we can just unplug this. So these, imagine these are all method calls, and each one of these is an interface. So we can unplug the power supply from the interfaces, and we could just test out these. So maybe we had little test modules we could put on these just plugs, and we could just plug everything into these, each of these test modules, and then we could test out if this power supply is working. In fact, the connection to the main, what we could think of the main program, is also plugged here. So again, I can unplug that. And so this is a portable testable unit. I can just pop that out. I can hook it up to different devices, or little test items, and test out this whole thing. In fact, I don't even need a computer or a power supply. I can just plug it in. Maybe I can even test this out on with a battery or a generator or something like that, plug it in. And just about anything we own nowadays, hardware comes with interfaces, these plugs. Now, there are some standard ones that are used lots. So like here's a USB cable, both ends. And so these are real generic. It's harder right now to get generic software interfaces, but we see a lot more specific hardware interfaces where we can connect things together. So, I mean, if you just think everything, I mean, it used to be, when I grew up, the phone in your house was hardwired into your house. The cable, you had actual physical phones, and they were hardwired. They were owned by AT&T, and they were hardwired into the house. If your phone broke, you had to call AT&T. They sent someone out. They had to unscrew this box, unscrew these wires, and re-screw in a new phone. Nowadays, if you even have a phone, there's a phone plug you plug in and left. So that's kind of what an interface is. You don't hardwire it in. It's a plug you can plug in and plug off. So let's go back to sharing here. So we're going to talk a little bit about interfaces, and basically an interface, requires code to implement certain methods for it to work. And we're going to go through this simple example of a simple interface here and do it now. This goes through and talks about this interface. So we define an interface, a public interface called simple interface. And then in our class, we define an object that implements that interface. Inside this interface, we might declare a method saying this is one of the things this has to do, and in our object this has. So this is a good example, but it's not part of the main program, and it's missing some things. So I'm going to go over to Brightspace. I'm going to go to this chapter 4 examples on GitHub, and I'm going to actually download that into Visual Studio so we can walk through it. And again, feel free to do that. It's not required, but certainly you can. I'm just going to clone that, paste that in there, and clone that down. Another thing you can do is just in GitHub, you can just go through here, and as I'm talking about these different programs, you can just look at them also inside GitHub. Okay, but I'm going to load them into Visual Studio so you guys can see them kind of in Visual Studio. So let's look at this, how this might work hardwired without an interface in any way. So I'm going to open up the main program here. I'm going to create an object that without an interface again. So the object is called Simple Interface Implementation, but it's not. We're not going to use an interface right away. So I'm going to just declare a new object of that type. Get this on the screen. A new object of that type, and call S. And here's the constructor for that. And once I have this object S here, I can call it. So what does it do? It has a couple methods. This method requires an implementation. This needs to be implemented. This is an integer, only needs a getter. So just some sample kind of methods in here. And you know how you call it. If you have an object, you call the method, you just say s dot and you call that method. s dot, you call that method here. So here's our simple version without an interface. And now we're going to do it with an interface. And it looks basically the same, but when we declare the variable, we make an interface a type of it. So what we're going to do is define this interface and list the types of messages that you could handle this. So when I imagine each one of these methods is like a different pin. So like in our cables here, you might have an interface with 6 pins here. This one only has 5 because one of them is empty, but so it's 5 of the 6 are used. This one only has 4 pins in it. So this interface requires you to implement 1, 2, 3, 4 methods. So that's kind of the shape of that interface. You need to implement 4 methods, and this is what they're called, basically. This is the shape. And again, just like here, every interface here, make sure you don't plug in the wrong one. It has a certain shape. This corner is bent so that if you have this, you won't be able to plug it into that. So each one has a different shape, and that's what interfaces are kind of like. This thing has a shape. We're saying you need a method of this type. You need one of these methods that returns a string. This one has to return a void. This one has to return an int. This has to be an event handler event. So this is your interface. So now in our main program, we declare an object of that type. And we declare our object here, just like we did before. And so with this object, for this to work, it has to say it implements this interface. I'm going to get rid of this for now. So if I had this class here, and in our main program, I would now get an error saying this, you cannot implicitly convert from this into this interface type. This doesn't implement this interface. So basically, when we have our objects, we say they implement a certain interface here. So this is called the simple interface. And for this to work, it has to implement all these methods. The methods that are here have to be here, right? So I think this is all reviewed for you. I'm just kind of going over the basics to remind you where we're at. So if we did not have an interface of the right type, or it was a different structure here, maybe this was an int instead here, then we'd get an error on this interface, and it says it does not implement this one method properly. Okay, so you'd get an error because it would say, okay, you have to implement these 4 methods, and you are implementing 4 methods, but they don't all match. They're not the correct shape. This one should be a public string, and it's a public int. And then so, again, if you have it correct, then it'll fit. The 2 software components will fit together. So interface is basically what we're saying is that in our main program, here we kind of hardwired things together. Now we're saying we're going to stick an interface between so we can plug in this implementation into this interface and use it here. So that's all they're trying to do in the textbook with this example, showing how this interface works. Now, in Java, interfaces had to only have methods, could not have any data in it, and that's generally how they work. Now in C#, they will let you add properties to interfaces and getters and setters. A lot of people still will avoid that because the whole idea of an interface generally is not to have any data in the interface. So again, Visual Studio or C# lets you have properties, not variables, but properties, which are kind of like variables, in an interface. But again, some people swear against those because, again, it kind of breaks the whole idea of an interface being just something you plug together with no data in it. So, So why, well, what are the benefits of interfaces? One of them is multiple interfaces. So you can have a method that implements two different interfaces. So you can have two different interfaces up here and you'd have a method that implements both of these. Now, why would you want to do that? Well, often you will have objects that have to do different things. And I've seen objects that I'll implement, 8 different interfaces. For example, let's say we do Visual Studio C# in game design. Let's say we have in game design, we have a weapon that we're doing. So we have these, we created an object, we created a weapon. Remember, you were in game design. We created these objects here, and you wanted a couple things. Maybe you wanted it to be storable in inventory. So in order to be storable in inventory, it needs to implement a couple methods, a display icon method, and a couple other ones. So you would create a interface for inventory, an iInventory item. And it would have to do the right things for an iInventory item. And then all sorts of things would be able to put in inventory. So your weapon would be implement the iInventory interface. Well, maybe this weapon also is something that can cause damage. So maybe, and again, lots of things cause damage. So maybe you have an iDamage interface. And so when you use this weapon, you say, well, okay, give me how much damage it costs, and maybe tell me how it might animate, or what kind of if it has only so many usages on it. So maybe you'd have an iDamage interface that would have a couple methods. And so if you have an object that's going to be used as a weapon for damage, or any, maybe it's a spell that can be used for damage, or some other object, they would all implement this interface. Yep.
So then what's the difference between an interface and an abstract class? Can't you just do that with the
Yeah, so what is the question? What's the difference between interface and abstract class? They're very similar, and in a lot of ways, you could just do an abstract class instead of an interface, except there's multiple inheritance or multiple interfaces here. And so again, we can have a root class that can implement two different interfaces here. But what if we try to do multiple inheritance, that has problems. So if we had two different abstract classes, if we have a root class that implements tries to inherit from two different objects, that doesn't work. Most languages do not let you do multiple inheritance. And so, although with object-oriented programming, you learn what inheritance is. You learn how to make child objects, inherited objects, and sometimes those work, particularly when there's a hierarchy. A lot of things that we used to do with these inherited classes, we're now doing with interfaces instead, because we found that you want to do multiple ones, and you can't. So it's real common to have an object implement multiple interfaces, and you can't inherit from multiple objects. So this is one of the main arguments for using interfaces so often rather than inheritance and abstract classes. So, okay, now I'm going to skip over whole sections of this chapter because I just don't think they're that important. So there's this explicit implementation. We're just going to skip over that. We're always going to use implicit implementations and how they work for this. So I'm going to skip over all that stuff on explicit implementations. It's just not something used much. Okay, now I'm going to get down here to, again, polymorphism, which you were just asking about. So often we'll have an interface. Well, this is kind of related. One of the reasons for using child objects and a parent object is that you can do polymorphism. So you can have a weapon object, and then you can have a sword object, you could have a dagger object, you could have a mace object underneath that. And then they can all act as the parent weapon. But again, we often want to do multiple, we want a weapon to also not only do damage, but also be an inventory in other areas, maybe displayable, stuff like that. So we'll do this. We can do polymorphism just as well with with interfaces. So we'll define an interface like iVehicle, and under iVehicle, we'll have multiple different objects that will implement that interface. So this interface, again, imagine it just like a simple plug in a wiring scheme. So you're just defining what are the 4 pins this interface has to do. It has to define start engine, stop engine, steer, and accelerate. So then anything that has that plug on it can plug into this iVehicle interface. So we can have a car with those 4 methods defined, or a motorcycle, or a speedboat, all defining those 4 methods. Here. So I'm going to jump back into this example in Visual Studio for a sec before we go on to the next design pattern and talk a little bit about this polymorphism stuff. Okay, I didn't love the book's example with the simple interface example. I mean, it's nice because it tried to say it's simple, but I sometimes like to see something more practical. So let's say we want to define objects that we can sell at like on a website or something like that. So like we're going to start up Amazon, our own version of Amazon. We're going to call it Mississippi, pick a different river to name it after maybe. And we're going to sell things on it, books and other things. So we'll have a book object and we'll have information about that book. Okay, so that's our object. And then in our main program, what? Oh, oh, those screens went off. I always struggle with those screens, Dan.
How do you fix them?
I think I've been shown how now, but I don't know why they keep going loose.
Big John Schockenbauer on it.
He knows about it. He showed me this fix. He said that will fix it. Oh, it's interesting. I see the problem. There's a wire that's shorted out here. Huh. Yeah, I was trying to fix that. Okay. There. All right, sorry. Loose wire. Okay, so we have our book item, and in our main program, we're going to be able to do things with these books or other objects. And so we're going to want to bill customers with it. So I'm going to want to create billable items here. So I'm going to create a new book, and then I'm going to say, print the bill of this. But I don't want to just be able to print out books. Bill books, I want to bill lots of things. So print bill will be defined as an interface. So I'll make an interface called iBillable items. So what do I need to do when I print out a bill? I'm going to have to print out the bill description here. So this interface is just going to make sure it implements this print description line. So I'm going to make an interface and have it have a print description in it. Here. Maybe I also want to print out the cost of it. So I want to make sure I can have that. So again, when I'm making this billable interface, I have to kind of ask myself, what things do I need to print a bill here? So maybe I think, well, I want to be able to print off the description. I want to get the cost. I might want to calculate the total shipping weight for my shipment. So maybe I want to get that amount from here. And so I'll define this interface here, and then my method will implement, the parameter will be one of those interfaces. And then in my main program, I'll declare a book. And I just have to make sure my book implements that interface. So again, here's my book object, and it implements this interface here. And so then I can, in my main program, I can declare a book, and I can pass it to this method that just requires an interface. So print bill doesn't have to know anything about books. They just have to know that it's going to be given some object that implements this interface here. And that's what we're kind of showing with this polymorphism here, is that we could have different billable items and we could create different ones. Because again, there are other places where with a book, I might want to store different data. Might want a person to do a preview. So there will be different things a book can do. But one of the things a book has to be able to do is be a billable item. So this interface allows, puts a plug on that lets it be a billable item. So, and then now I can make other objects. Let's sell something else. So I'm going to add. So right now I just have my interface and I just have a book here. Let's add another object that can pretend to be a billable item. So I'm just going to create another object. What else should we create? New item. So let's just sell an electronic component. Maybe this would be a phone or some sort of gadget like that here. So I want to keep track of the name. Cannot type today. Again, I want to keep track of its cost. In Visual Studio, we use this thing called decimal usually as a special type for keeping track of dollar signs. A lot of languages, it's often hard to figure out what you should be using to keep track of dollar amounts because you need decimals, but floating point numbers have some kind of rounding problem sometimes. So often languages will have their own specific value to store decimals and that sort of stuff. And I might have some other items here that this thing will have. And then now I want this to implement this interface. So right now, if I go to my main program, I declare a book. I mean, not a book, an electronic item, phone. Oops, yeah, new electronic. I'm going to create a constructor with this. Let me just do that real quick. There, okay. So now I can say new electronic item, call it constructor, and one thing that when you do use this currency stuff, it requires a suffix so that it knows what kind of type in it. So it's the M is kind of for money, I guess. I don't know what the M is for, but when you hard code a actual physical thing, you have to put an M after it to show that it's a current or not currency, a decimal item. So, okay, so I've created this phone. Now I can let's say I want to add this to the bill. I'm going to say print bill and pass this phone to the bill. here. But again, I'm going to get an error because again, this electronic item doesn't implement an interface, and this is expecting an interface here. And so it's going to say it cannot convert from an electronic item to a billable item. Okay, so again, I need to make sure that so this connection here to this interface is not there. So I'm going to want to make sure my thing implements an interface. So I'm going to say implements an iBillable interface. iBillable item interface. Now, in order to do that, it has to print off, implement 3 different methods, and it doesn't here. So I have to add those methods into this. Actually, I think if I just click in here, I can just tell it to implement that interface, and I'll just put blank versions of those that just generate errors for now. And then I can clean it up. But at least this is the right kind of interface. So get cost, I can now change that to return cost. And print description, I can change that to return a string of the inscript. So I could set that up. So once I've implemented that interface now in my main program, I can pass my phone to this iBillable items. So both this electronic item and this book now can be treated as an iBillable item. Kind of like here, if we're implementing this interface, both a car, motorcycle, or speedboat, any of them can implement this interface, can be passed and disguised or plugged into that sort of routine. How's this going out there? Does this all seem like review? I think this should all be reviewed. Is this kind of reviewish? Yeah. Good. So, okay, now we're going to get into some newer stuff. Some design patterns. So design patterns, the term was kind of coined back in 1994, so over 20 years ago, over 25 years ago. And what they're trying to do is, again, create larger structures for software that we will use again and again. It's kind of like when you look at your phone or your tablet or even a computer. Initially, if you go back to the early computers, everything was hardwired together and there wasn't any modules that you could really snap in and out. But eventually when we made more and more of them, we kind of got used to it. We go, we need to make this more modular so that when we move from one version to another or we update stuff, we can just take a module from one place to the other. Or when we hire someone from one place to another, or move a person from one project to the other, they can see patterns, they can see stuff. So that's why, nowadays we have these power modules that you can pull out from one computer to the other. And if you do hardware work on it, not all power modules will be the same way. They won't have all these interfaces, but there's going to be a power module. It's going to have plugs on it here. And I should be able to just unplug it and plug in a new one. I might have to get a different one. It might have different shape plugs, but that idea will be there. And that's what design patterns were, trying to define these structures and how it worked. And originally they were all defined with inheritance and abstract classes. But again, we ran into problems with that. So within the last 20 years, they've been rebuilt with interfaces. So now they rely almost entirely on interfaces. So let's look at one, the null object pattern. So there are times when you're going to want to return a null object for stuff. Let's say you are having a website and you're listing students and clubs, and a person can type in a student ID, and then you go out and find that student and return that. What if someone searches or gets a student ID, puts it in there, but it's not in the database? How do we handle that? And there's different ways of doing some null checking, but one way is sometimes just pass back a null object for this. I'm going to show you some code because maybe you haven't written very complicated code that does lots of null object stuff. So back in this video for chapter 4 page, I have a null object example. This is an old example. It's probably 15 years old, and it's in an old version of Visual Studio. I mean, in Visual Basic. And so back in Visual Basic, they didn't have something called null. They had they didn't have null. They had something called nothing. I just want to show you this cascading check for nulls and how often we check for nulls. There's some code that went out to Amazon, got a list of books, went through that list of books, and got out every list that book was on, and then went on to those lists and got every book that was on those lists, and kind of crawled through the whole list database in Amazon. But you can see these checks. You just highlight some of these. So here we're checking if this array, we're given an array and we're checking if it's nothing, if it's null. And then we're going through each, we're looking at the first item in that array and seeing if that's null. Now we're doing these if-thens, and we have a whole list of if-thens. So here, while the array is not nothing, and then when the array, this is an array of lists, and we're going to check for each list, we're going to check if the list is not nothing. So if we're in an array of lists, and then we're going to check each list to make sure it's not nothing, that they haven't deleted that list. And then we're going to go through the list of books on that, the list of items here. So again, the list has a list array in it, so we're going to check if that's not nothing. And then we're going to go through each item in that list of arrays, and we're going to check if each item is not nothing here. And then here, you just see these constant checks for not nothing, for null. And it makes sure that this will work in these cases. So again, this is kind of an example of code that the book is trying to explain, that often we're checking if something is null again and again. We have this plethora of null objects checking in code. Often your code is basically, half your code is checking if there's a null object here and then doing something instead. So to get rid of that, sometimes what we do is we'll define an object that's a null object that implements these things, but in a null way. The problem with this code here, and the reason we have to check this, is that we can't, if we don't check this, then when we try to go to list.lists, it'll crash. It'll give us a runtime error and the whole program will crash because there is no list of lists. So we wouldn't have to do this check if we could get a list, if this object would return a null list of lists or something, would return an empty one or something like that, but it won't return anything here, and this alone will crash, give us an error. And so again, what we're trying to do is define null objects that will define our requests and just do it in a kind of empty sort of way. So our client, our program here, our main program, will go through this interface, and then we'll have our real objects implement that interface. And we'll have also null objects implement that interface. But the null objects will implement it in a different way. An example of this is for testing. We often test with a database here. So you might have your client access a database through an I database, or I CRUD interface or something like that. So you want to say, read this person with this ID or something like that. And then you'll have a real database that'll have a create, a read, an edit, a delete method. And your client will interface with that database with the CRUD interface. So there'll be a read method, like a request method, an edit method, a delete method. Now to test this, you might not have your database available for testing. So you'll create a null database out here that will do all those things, but in a limited or a non-faction. So your main program might say delete, customer 27, and then it'll go out here and it'll call in Null Object say delete customer 27, and it'll say, okay, I deleted it. We don't have a database. We'll just pretend it's deleted. And then here it might say, give me a list of customers and from the databases. Okay, we don't have a list of customers. Here's just a fake list of 2 customers, or here's a list of no customers that'll return. So it would do the create, read, edit, delete that this does, but just in a null fashion. And then for testing, we can just basically unplug this object and plug in this object in its place. So that's kind of what this null object pattern is doing it in this interface. And we'll look into some more. We have an example here talking about that. We'll see if we get to that today. If not, we'll do it as part of the participation stuff on Thursday. Don't think we're going to get to it today, it looks like. Oh, and I've got this updated. It's a zip file. It needs to go to a GitHub. I'll have to update that now that I look at it. It shouldn't be a zip file. Okay. So this example will implement this interface here where we're talking about a user repository, and we're going to create a session ticket and stuff. So we'll go over this example probably in a participation activity on Thursday. So I'm going to skip over this stuff for now, and we'll return to that null object here. And again, this talks about this cascading nulls. Again, where we just have a whole sequence of nulls. First, you have to check if the person is null. And if the person isn't null, then you can look at the person's details. And if the person's details aren't null, then you can look at the person's details age and then check things up. And we often have these cascading nulls here, and we have to do all these checks. So before we can look at age, we have to do these other checks. But if we have a null person pattern, we can often just do something like this. No, this is a shorter version of the app that we can look at. And so far you guys have seen the dot implementation. So if you say an object dot a method, right? There's a question mark dot method also, or operator also, which will check, because normally a dot method will just, if details doesn't exist, will just crash. Where the question mark dot will say, check if details exist, and if not, then don't go any further for this. What the book's also talking about is an anti-pattern here, and this is this constant null check. And this is what this code was doing, is this constant, again, in Visual Basic, it was nothing. It is this constant nothing check. If you look at this code, almost a third of this code is checking for nulls here. And again, that's why they listed it as an anti-pattern. If you can just check if this is null, if this user is null, it's just often not a good way to set things up. But again, it is done all the time. You see lots of code where there's lots of checks for null out there. Okay, I'm going to leave this again because again we'll be returning to this example on Thursday. So that was one pattern. Here's another pattern. It's called the adapter pattern. for this. So the idea is that you might have some method, some object out there that you cannot change. But your new software's got to be able to handle that old thing that can't change. How do you use your new software on this old thing that can't change out there? So, and I'm sure you've done this in physical, think of physical things you've done. So I have a new phone and it's got a USB-C plug on it. So I've moved all my chargers to USB-C stuff. So all my things are USB-C. Like, so in my office, I have a USB-C cable to charge my phone. In my office at work, I have one. In my bedside, I have them. I have them all over the place now. So I'm used to doing USB-C. But I still have a couple things. My headphones, my Bluetooth headphones are not USB-C. So how do I plug in my my micro USB headphones into all my USB-C cables here? And what you do is you buy an adapter, right? You buy a little plug that'll convert USB-C to micro USB. And so think of where you have these adapters and how these are. Just this weekend, we had an electrical plug that has 3 prongs on it, and we're in an old house we're fixing up that only has 2 prongs in it. They don't go together. So there's a little plug that you put on to convert a 3-prong to a 2-prong plug that goes on this. So that's what this adapter is. There's some software that you cannot change. The idea is that this software you cannot change. So why? Typically, it's old software written in a language that we're no longer maintaining or supporting. So maybe it's an old COBOL program. It's amazing how much old stuff is still running in it. Like Securian, they still run a lot of old mainframe systems.
The thing we used to like log our hours was from like the 90s.
Yeah, right. So there's still these mainframe modules or these stuff. So this proven code out there, they don't want to change. So, but they have the new web interface that's going to go to this old code. So how do you have the web client talk to this old code? You write an adapter there that will connect up to the old code. And that's what we're looking at here. So if our client expects a certain interface to be built, we're going to define an adapter that's going to do that, implement that interface. So now with this class adapter, or this with adapter pattern, there's 2 ways of doing it. One way is with what's called the class adapter pattern. You make a whole new class that implements this, which you can do, but we're not going to look at that because, again, modern ways is to do this with interfaces. So this whole section on the class adapter pattern, we're going to skip over, go down to the object adapter pattern, and we're going to do that. So we're assuming we have a client, our main program or something, and it expects some interface to be implemented here. And we have some old software out here that doesn't implement that interface. So we're going to stick an adapter in here so that our client, this adapter is going to implement this interface and transform it over here. So that'll let us connect our new client, or like our website. Our website will be, maybe we're displaying, we're showing books and stuff like that. And so or maybe we're tracking hours. So maybe we want a new website to display the hours we've worked at Securian. So this is our web client. Our interface is to, an hourly worked interface or an employee interface after that. But the actual employee stuff is all in some old 1990s database system. So we define a little adapter here that talks to that old system, translates that data, and puts it in here. So maybe the old system didn't store things in the currency data type, had it stored as integers or floats or something like that. But the new interface expects things to be stored in a currency or a decimal or a certain way of doing it. Maybe this is an old database with old SQL stuff, and we're getting the data only in a certain way from it. This adapter will translate it. So with the method A and B here, with our target, there's only certain methods we can define into that. So method B is the only thing we can get from this old payroll system or a whole hourly work system. But our new web client wants method A invoked. So our adapter will implement method A, but in that it will call method B the target and then translate, do any necessary translation to put it in here. This is sometimes referred to as middleware, software that's used to in the middle between two different systems to interface with them. It's kind of hard to see this without a practical example. So that's on Thursday, we'll go through, we'll see, certainly on the assignment this week, you'll go through an actual physical example of this sort of object pattern. So again, we're not going to do this class adapter pattern. We're going to look at the object adapter pattern, which uses an interface for this. So I'm not going to go through this code that much. I think the picture is helpful, but again, this code basically tries to show this exact picture here. And again, I think it's better to look at a larger code segment, and so on Thursday we'll look at a larger code segment of this. Okay, so we have our null pattern, we have our adapter pattern, and we have our strategy pattern. And again, the reasons for these patterns is that, you'll see these adapter patterns a lot, so that when you're starting a new job or whatever, you say, you just know to look for things. Oh, you must be interfacing with the old system here. You're probably creating an adapter object that implements an interface and then calls the old stuff on the old system. So that's, it may not be called an adapter object, but that's what it is. Sometimes it is just called an adapter object. So this is another pattern, the strategy pattern here. And this uses polymorphism to implement things. So I have a client which will be doing some things and have a couple different strategies that will be available out here that it can implement. Now, sometimes these strategies, what you often will, let's say you want an object, you want something to be able to do different things in different places here. So you can set up some ways of doing this. Maybe you have maybe in a game you have non-player characters and they have different strategies they can implement, they can do. A non-player character might have a roam strategy, might have an attack strategy, might have a runaway strategy to do that. You can set up your non-player characters so that you have a bunch of if-thens. If this is true, then do this. If this is true, then do this. And have a whole, define different strategies and different ways of doing it. And it gets kind of messy. So this is the idea of kind of simplifying this. The idea is that you define a set of objects that implement different things. So you'd have an object that knows how to run away. You'd have an object that knows how to attack. You'd have, and then each one would just have one method called execute. You say, okay, whatever we're doing, just execute the strategy that we're doing. And then it would go off and do that for you. And then your client doesn't have to worry about all these different strategies and have to have a bunch of if-thens objects in here. It just needs to have maybe it has an array of non-player characters. It goes through each array of non-player characters and just execute each non-player. No, execute the strategy for each non-player character and have it do whatever it's supposed to do for that. And so you can have these different strategies out there. It's called the strategy pattern, but it's actually used at a lot of places, again, where we want objects to behave differently in the same way. It's kind of, in some way, this billable we talked about earlier kind of is the same thing. We want everything to be able to do a billable thing. Again, just basic polymorphism. And in our program, we can create these different objects and we can have them do all billable things. A little different between just common polymorphism and this strategy pattern is that in the strategy pattern, you generally only have one strategy running at a time here for an object. So either do it this way or this way. So again, it's kind of showing you how this strategy pattern works. So we're not going to do much in the examples of the strategy pattern. So this is all we're going to see. To tell you the truth, I don't see the strategy pattern used near as much. The adapter pattern, the null pattern, there are some other patterns, and we'll get into the solid patterns in the coming chapters. They'll implement them up. In the coming chapters, let me just pop those up. So right now we're in part 2 of the book where we're just doing, talking about some of the basics, interfaces, testing, and refactoring. After we get done with chapter 6, we get to the main heart of the book, the solid code. And this implements 5 really well-known patterns: single responsibility principle, open closed, Liskov, substitution, interface segregation, and dependency inversion. So each unit here will be a larger, more complicated pattern we'll get into. So just so you know what's coming ahead. But we have a couple weeks of just these basic sort of stuff. So again, they wanted to introduce what patterns are, because again, much of the main part of the textbook is patterns. And so they just picked 3 common, relatively simple patterns that are out there. Now, there are lots of patterns. You can just Google patterns, software patterns out there. There are whole books that define cookbooks of different patterns. I find them sometimes hard to understand unless, so there are some good books out there that actually have specific, or websites that have good samples of these things. And that's why here, these are 2 examples. So here's another example from Tudor's points of the object adapter pattern, walks through that. And again, sometimes when students go out there and look for the object the adapter pattern, they end up with the wrong one. This is an object version of this that uses interface that I think is pretty good. Oh, and just so you know, I mean, this Tudor points, look at, these are all different patterns they have out there. There's the null object. These are all different patterns that are out there. And then this is an example of the strategy pattern. Again, the one that's here is not the greatest. This one is, I think, a little better. So again, normal behavior, defensive behavior, aggressive behavior, and we have some robot that can choose between those behaviors here and set that up. And then they have actual code that shows how it is set up and run. So I like, that's why I put those 2 examples in this additional resource. I like those. Okay, now we're going to skip over a bunch of this next section. So duck typing, idea is that if in some languages, especially languages that aren't statically typed, where like Java, every object, you have to declare it as a variable of that type. It has to be an integer or a string or something like that. That is not true of C#. So in C#, when we declare an object here, for example, we're, let's see, where's our, so if we say this string here, item name, we could actually just say var, I think, and make it a generic type here. So you can declare object, or at least parameters, maybe not here, but you can declare parameters of generic types here. You don't have to specify the exact type of an object. Generally, that's frowned upon, and and we will not be doing that in this class. There's some code out there that sometimes uses that, but again, C is not always typed, and so the idea is, and Python certainly isn't typed at all, very much at all. So in those languages, we get into this duck typing, where the question is, when do we assign things and then it gets into this whole interface stuff. So, and we're going to skip over all of this stuff. Also, this dynamic language at runtime, again, trying to do some conversions and dynamically assign what type things are here. Impromptu interfaces we're not going to worry about here. We're going to leave those be. So we're going to skip over a bunch of this stuff on the second half of this chapter. I just don't see it as that useful for what we're doing. I just want, if you can get through this and understand these interfaces, these three basic patterns, that's fine. I will, at the end, they talk about fluid interfaces, and I will mention that. So you may start seeing this where we can chain together a bunch of method calls. You often see this. Yeah, let me just grab this code and post this into this. You often see where you have some object and it'll call some method, and then that will call some other method, and that'll call some other method. Have you guys seen methods call, where you chain together a bunch of method calls like this? Where you have method, like in game design, we do that some when we're calling, we'll say, get this thing and then get this or do that. Well, we'll chain these together sometimes. Android sometimes does these chain method calls also. And how these work is that this method will return some object, and this will call a method of that object, and will call a method of that object. And that works generally all the time. But with methods, often sometimes this will be the same object. So if you define an object, it will return itself so that you can chain together another object, and it will return itself, and you can call it again. So what you often see in code, for this to work, so rather than doing like this, where you say fluent.do something, this is your object, and then you call that object do something else, call it out, do something else, you call it out, you do it again and again, you'll see some structure like this, or again, all on one row here. In order for this to work, every one of these methods has to return the main type. So every method in this object will return a value, that interface object again for this. So we see a lot of return this. Every method will result in a return this. So again, sometimes you'll see well-defined interfaces set up so they return, if there's nothing obvious they need to return, they'll return this. And then that'll let you chain together these objects or these calls again and again. I just see often when people go out and actually start real programming, they'll come across examples like this, and it'll confuse them. And just know that this is our object, it's calling this, and then that is returning that same object, and we're calling this on that same object that we're returning. And again, sometimes this is called chained methods, and sometimes it's called fluent interfaces. Okay, so that's the chapter. I'm going to stop this recording.